Welcome to AI Dispatch, your channel for the latest AI videos on YouTube. If you don't want to miss these updates, please like, subscribe, and share. Today's video comes from EO, featuring Mihail Eric, an AI lead who also teaches at Stanford. He argues we are witnessing the birth of the AI native engineer, a shift where top CS grads struggle for jobs while naive junior developers hold a startup superpower. The new elite skill isn't coding, but management. Before we unpack these radical ideas, let's get a clearer picture of who Mihail is and why his frontline experience at Stanford is so crucial. Today's guest is Mihail Eric. He leads AI at an early stage San Francisco startup and concurrently teaches at Stanford University. His course, The Modern Software Developer, is one of the first to focus on AI across the entire software development lifecycle, making him a leading voice on AI native engineering. Let's hear his take on the coming disruptions. A computer science graduate from UC Berkeley, one of the top programs in the world, sends out 1,000 job applications and receives only 2 replies. Mihail Eric, who teaches the Modern Software Developer class at Stanford, says this is not a statistical error. It is the first signal of a complete restructuring of what it means to be an engineer. His claim: we are witnessing the birth of the AI native engineer, a shift that turns the traditional hierarchy of software development upside down. Mihail teaches a class at Stanford called the Modern Software Developer, which he describes as the first of its kind to focus on AI across the entire software development lifecycle. When it was announced, it filled up with over 100 students trying to enroll within just a few hours. It's in this role as an educator on the front lines that he's seen the ground shifting. He spoke with a recent Berkeley graduate who had the exact experience mentioned earlier. After applying to roughly 1,000 jobs, he only heard back from 2 without even landing an interview. It's a stark illustration of how dire the job market has become for junior engineers. Let's begin with the engineering and architectural disruptions he identifies, starting with a concept that runs counter to mainstream thinking regarding automation. Everyone assumes that to build more powerful AI systems, you simply add more AI agents to the workflow, like adding more workers to a factory line. Mihail Eric argues that adding more agents often makes the system significantly worse. His logic is based on the mathematical reality of compounding errors. If an agent has a slight misunderstanding in step 1, it doesn't just pass that error along, it doubles down on it in step 2, magnifying the mistake exponentially. He compares this to managing a team of eager but inexperienced interns. If you let them loose without structure, you don't get faster development, you get chaos. His diagnosis: the bottleneck in future engineering isn't computing power, but the architectural containment of error propagation. Mihail has a lighthearted but powerful analogy for this. He describes AI agents as very eager, savvy interns. They work incredibly hard in the terminal, executing tasks at lightning speed. But just like a real intern, they can get stuck, go down the wrong path, or start hallucinating solutions. At that point, they need a human manager to step in, provide new context, and redirect their energy. It's a simple image that perfectly captures the need for human oversight in a world of automated agents. He introduces the concept of an agent-friendly codebase. Conventional wisdom is that code is written for machines to execute and humans to maintain. He points out that in many projects, the documentation, the README file says one thing, but the code does another. A human developer might figure this out by asking a colleague, but an AI agent will hallucinate or choose the wrong path, creating spaghetti code. He believes that for the first time, we must write code specifically for machines to read and understand, not just execute. If your code isn't consistent in its design patterns using API A in one place and API B in another, the agent will derail. Strict, almost rigid code formatting is no longer just about aesthetics. It is a functional requirement for the AI to operate at all. Even more mind-bending is his observation regarding how the most advanced AI tools are actually built. He cites the team at Anthropic, noting that they essentially rewrite their Claude model every 1 to 2 weeks using Claude itself. Traditional engineering dogma of stable releases and long-term foundations doesn't apply here. Instead, he describes a recursive loop where the tool is constantly rebuilding the tool. There is no static gold standard anymore. The creators themselves are discovering what works in real time, suggesting that modern software engineering has moved from a discipline of construction to a discipline of continuous recursive discovery. Mihail shared a stunning real-world example of this from his own network. He had a guest speaker named Boris from Anthropic's Claude Code team visit his Stanford class. Boris revealed that the team essentially rewrites Claude itself every week or two using Claude. It's a striking example of dogfooding at a scale that was previously unimaginable, where the AI isn't just a tool for the product, but a tool for its own reinvention. Now, let's move to the logic inversions regarding the workforce and human talent. We intuitively believe that senior developers with 20 years of experience are the most valuable assets. Mihail argues that senior engineers are often the most resistant and least effective at adopting these new workflows because they are scarred by decades of doing things the hard way. They look at a complex problem and instinctively recoil because they know how difficult it traditionally is. Conversely, he believes junior engineers possess a startup superpower specifically because of their naivety. They don't know how hard healthcare or finance integration is supposed to be, so they just let the AI tackle it. In this new paradigm, deep experience can become a liability, while a lack of scar tissue becomes a competitive advantage. He saw this exact dynamic play out in his own classroom at Stanford. Mihail observed that the students who performed best in his class weren't necessarily the ones chasing the highest grade. They were the ones who got so excited about their class projects that they kept building them into actual startups after the course ended. They were driven by a genuine passion to solve a problem using AI as their superpower, completely unburdened by whether it was supposed to be hard or not. Mihail Eric states that the last boss of engineering, the skill that separates the elite from the average, is actually management. Because AI agents act like interns, the engineer's primary job shifts from writing code to context switching and delegation. He notes that people who have managed human teams are actually ahead of pure coders in this regard. The ability to remember what Agent A is doing while unblocking Agent B is a managerial skill, not a coding one. An ontological shock emerges. The best software engineers of the future may look more like great people managers than great programmers. He argues that multi-agent orchestration is essentially the same skill set as being a good human engineering manager. The best multi-agent users he's seen are people who have managed human developers before. They instinctively know how to delegate, how to check in on progress without micromanaging, and how to unblock someone who is stuck, whether that someone is a human or an AI. Finally, let's look at the economic implications of these shifts. Rem Koning from Harvard Business School, who also appears in the discussion, presents a paradigm-shattering view on where the real value lies. We currently obsess over AI tools that help humans work. He suggests a different question. What happens when AI starts talking to one another? He predicts that the next trillion-dollar companies will not be built on AI to human interaction, but on AI to AI collaboration, where the human is entirely out of the loop. The economy shifts from humans using tools to humans allocating intelligence into a system where the agents negotiate, trade, and build among themselves. However, amidst all this optimism, there is a grounded warning about the danger of this new power. Mihail Eric cautions that with tools like Claude and Cursor, you can easily spend a month building the most beautiful, complex piece of software imaginable, over-engineered to perfection, only to launch it and realize nobody wants it. The ease of building creates a trap where engineers solve technical puzzles instead of user problems. During the conversation, Rem Koning captured this exact sentiment with a moment of humor that will resonate with anyone who has ever worked on a project. He described the trap of AI-assisted over-engineering this way. A month goes by and you've built the most beautiful piece of software. It's crazy over-engineered, and then you launch and nobody wants it. It's a funny but sharp reminder that the goal is still to serve a human need. According to Rem Koning's projection, we are moving toward a world where the defining metric of success is your ability to allocate intelligence rather than perform labor. When we look back at this transition period, the winners will likely be those who realize that they were no longer building software, but designing the organizations of agents that build the software for them. If you're interested in the video featured in this episode, click the link below to watch the original.